Elon Musk finally confirmed the rumored price of the Tesla Model 2, reinforcing his confidence in its design and praising the engineering team responsible for it. But what does that mean for an electric car costing just $10,575? Tesla's approach to the Model 2 blends unexpected elements from high-end sports cars like the Porsche 911 and Jaguar F-Type, infusing the compact EV with agility, balance, and aesthetic flow while keeping it practical and affordable. The company uses what engineers call scale dynamics, adapting the 911's low polar moment characteristics and the F-Type's long, fluid proportions into a smaller form factor, aiming to cut rotational inertia by up to 15% compared to competitors. This ensures steering feels responsive but not jumpy, giving driver stability during daily commutes and highway merges. The weight distribution sits near 48 of 52 front-rear thanks to battery placement and calibrated structural massing, giving the car neutral behavior reminiscent of a 911 without becoming difficult for casual drivers. Tesla stretched the wheelbase slightly beyond typical compact proportions, improving straight-line comfort while keeping overhangs tight for easy parking. Suspension tuning borrows concepts from Porsche's progressive anti-roll geometry and Jaguar's multi-link comfort, with softened springs and slightly stiffer anti-roll bars to maintain control without punishing the driver on rough roads. A steering ratio about 10% quicker than conventional compacts is balanced with software damping to avoid twitchiness, making lane changes confident and low-speed maneuvering smooth. Aerodynamics target a drag coefficient around 0.22 to 0.24, reducing energy use on long drives, adding meaningful miles to the range, and lowering anxiety for budget-minded or older drivers traveling between distant chargers. Inside, Tesla mimics Jaguar's tactile priorities, using cost-efficient materials that replicate the feel of premium interiors by matching textures and density to within millimeter-level tolerances. Instead of merely borrowing shapes, Tesla recreated the emotional feel of premium performance cars through electric architecture, tuning every mass and curve to deliver light, precise handling, and calm highway stability. But none of that matters if entry and exit aren't practical for everyday users, prompting Tesla to address the challenge of fitting Falcon wing doors into a low-cost vehicle. Unlike the complex, expensive multi-axis system of the Model X, the Model 2 uses simplified mechanical counterbalances and a single motor aided by over-centered dampers inspired by aircraft doors, cutting torque needs and reducing parts cost by about 40%. Switching from high-end aluminum to stamped high-strength steel with composite coverage slashes expenses further, bringing each door into an affordable cost range while retaining functionality. The simplified system still offers major usability improvements, increasing shoulder clearance by up to 2 feet, easing entry for older passengers, and preventing door dings in tight parking. Lightweight skins and hollow reinforcements keep each door within a tight weight budget to maintain handling and balance. Safety-oriented geometry limits water intrusion in heavy rain, and shared actuator components with other Tesla models keep long-term maintenance cheap. Beneath those doors lies Tesla's other major engineering hurdle: Gigacast components that once caused inconsistent stiffness and puzzling vibrations at speeds above 65 miles per hour. Engineers spent years solving these phantom issues, ultimately tightening alloy chemistry tolerances to prevent sections of the casting from becoming harder or softer than intended. Vacuum-assisted die casting reduces trapped air and porosity, while directional cooling pushes remaining imperfections to non-critical regions, cutting void volume dramatically. Post-cast heat treatment stabilize grain structure and keep dimensional changes under 0.020 inches on key mounting points, ensuring consistent feel and preventing mismatched stiffness between corners of the chassis. Targeted reinforcement using steel inserts and ribs strengthens only the areas that need it, preserving weight savings without sacrificing structural harmony. Advanced NVH strategies place isolators and tune mass dampers at key nodes, cutting vibration transmission by around 70% in the sensitive 20 to 30 Hz range that humans feel most strongly, eliminating the unsettling shudder found in early prototypes. Every casting undergoes ultrasonic inspection and thermal imaging to detect flaws, producing defect rates far lower than conventional stamped assemblies and resulting in long-term durability and quietness. Altogether, the Model 2 demonstrates that affordability doesn't require compromise, precision handling, aerodynamic efficiency, innovative doors, and structurally advanced gigacasting all come together in a vehicle priced lower than many e-bikes. Tesla's achievement challenges the entire auto industry, proving that high-level engineering can be democratized. As more breakthroughs emerge, the Model 2 sets the tone for what low-cost EVs can become, blending premium emotion with everyday practicality in ways experts once claimed were impossible. And as Tesla pushes its philosophy further, the Model 2 becomes more than just an inexpensive EV. It becomes a blueprint for how modern engineering can scale downward without losing its soul. The company's relentless refinement of structural behavior, manufacturing precision, and ergonomics transforms what should have been a bare-bones budget car into something that feels intentionally crafted. Even aspects most automakers ignore at this price point, like micro-vibration dampening, hinge geometry, or the tactile perception of interior touchpoints, are treated as critical components of the overall driving experience. Tesla's vertically integrated manufacturing allows every improvement in casting, software tuning, aerodynamics, or actuator design to ripple down across multiple models, slashing costs while raising performance. What emerges is an EV whose development story mirrors the evolution of smartphones. Features once reserved for premium products gradually becoming accessible to everyone. The Model 2 is Tesla's attempt to accelerate that shift in the automotive world. Its engineering doesn't rely on flashy gimmicks or superficial styling. Instead, it focuses on the kind of invisible quality that makes a car feel composed on a rough road, secure in a tight space, and predictable at high speed. Drivers who would never spend luxury car money still feel the benefit of a chassis that rotates cleanly through corners, a cabin that stays quiet on the freeway, and doors that accommodate their needs without compromise. And this is where Tesla's strategy becomes clearer. By making advanced engineering affordable, the company pushes the entire global market to catch up, reshaping expectations for what an entry-level EV should offer. The Model 2 sets a new baseline, not just for price, but for refinement, and hints at a future where the gap between budget and premium vehicles narrows until the distinction barely matters as production scales, and suppliers adapt to Tesla's simplified components. The efficiencies compound, driving costs even lower, while preserving the engineering that defines the car's character. This momentum could reshape consumer expectations worldwide, proving that even the least expensive EV can feel thoughtfully engineered, emotionally engaging, and thoroughly modern, setting a new global standard for everyday electric mobility. Tesla's Model 2 is shaping up to be one of the most disruptive electric vehicles ever, combining a wildly unconventional design, performance approaching the Model S, exceptional efficiency, and even the promise of 100% free charging, all while launching an astonishing starting price of $15,990. With production beginning in North America and wider availability expected in Q4 2025. Many are wondering how Tesla has managed such a radical approach, and whether the announced price is truly final or comes with hidden costs. Recent updates show Tesla moving steadily toward its long-held mission of making EVs accessible to everyone, reviving long-paused projects known as NB91 and NB93, believed to be the basis for compact, low-cost vehicles. These efforts are particularly strategic in China, where fierce competition from BYD has reshaped the market, and later in crucial U.S. regions such as California and Texas. Although Tesla froze its affordable EV program in early 2024, a global sales decline of 5.9% in 2025 appears to have pushed the company to resurrect the plan at full speed. Tesla is also expanding its ecosystem, notably by rolling out behavior-based insurance in Florida, its 12th region, allowing safe drivers to pay as little as $60 per month instead of the typical $200 to $250 thanks to real-time safety scores. This technological advantage is one of the reasons Elon Musk feels